Hi, welcome to Essential IT and Security Skills. I'm Charles Redman, Master Trainer, here to guide you through the essentials that you are going to need to land the job that you are looking for. In this series, we're going to talk about essential PC skills. I'm going to walk you through everything from software to hardware. Most people know me as a cybersecurity expert. Well, I couldn't have gotten there without learning the basics first. That's what this series is going to do. And then we'll move on in some later series with some more advanced concepts and techniques. But remember, it all starts with the basics. It starts right here, the essential PC skills. In this segment, we're going to talk about local area networking. You'll learn how to install and troubleshoot structured cabling. I'll explain to you the basics of TCP/IP, show you how to install and configure a wired network, and learn how to troubleshoot some basic wired network issues. While Ethernet is the dominant networking technology of today, it uses a standard unshielded twisted pair, or UTP, for its wired connections with an RJ45 connector. However, there are other cabling types that you should be familiar with, like fiber optics and coaxial cable. Fiber optics use light instead of electricity to transmit data. Fiber optic signals can travel much farther than Ethernet, up to 2,000 meters or more. Three of the more common fiber optic connectors are SC, ST, and LCMT/RJ. Here's a look at each of them. With fiber optics, you'll have your choice of either single mode or multi-mode fiber. It really depends on the purpose in which you're using it. Multi-mode fiber is best for relatively short distances. That would be shorter than 600 meters or so. While single-mode fiber is used for high data transfer rates over long distances. So the major difference between which fiber optic to choose, it all relies on the speed and distance that you wish to travel. Next, we have coax. Even the early versions of Ethernet ran over coax cable instead of UTP. However, today it's mostly only seen with cable modems and satellite connections. A coax cable has a center core that actually carries the signal, and it's surrounded by a shield of braided cable and then a plastic sheeting. Here's what a typical coax cable looks like. Coax, like Ethernet, has ratings. It uses an RG name. Primarily RG59 and RG6 is what you're going to see today. The coax standards are rated by impedance. Both RG6 and RG59 have an impedance rating of 75 ohms. However, the major difference with coax comes in the connector, whether you're going to use a B and C connector or an F-type connector. The F-type connector is the one that you're most capable with coming from your cable connection in your home. Next, we'll move to different type of network devices, starting with the hub. Hubs you might also hear called repeaters. You very rarely will run into a hub today because they've mostly been replaced by switches, mainly because when you're connected to a hub, all other devices connected to that same hub have to share the total bandwidth available. Switches, by far the most common interconnection device that you'll see in today's networks. They eliminate the problem that we have with the hub because each computer can use the full bandwidth available of the switch. Then we have bridges. The bridge is used when you're connecting two unlike technologies, like Ethernet and coaxial. A bridge is always going to have at least two interfaces, one for each of the different types of media that you're going to connect to it. What's a network without storage? A NAS, or network attached storage unit's entire purpose and being is to share information. Basically, a NAS is nothing more than a headless computer. There's no monitor, no keyboard, and no mouse. However, it can store an entire organization's worth of data depending on the size. Next, we have routers. A router connects a LAN using the TCP/IP protocol. A router must have at least two connections, one into a network and one out to another network. Now we'll talk about structured cabling. Structured cabling standards are defined by the Telecommunications Industry Association Electronic Industries Alliance, or TIA. The whole idea of structured cabling is to create a safe, reliable cabling infrastructure for all of the devices that may need interconnection. So, as I say, it's always best to start at the beginning, the cable basics. Most networks are in a typical physical star configuration. A structured cable network requires three essential components: the telecommunications room, horizontal cabling, and a work area. Each of the three parts of a basic star network must follow a series of strict standards. Horizontal cabling is a Cat5e or better unshielded twisted pair cabling. But when you move into a structured cabling, the TIA standard define a number of other aspects about the cable, such as whether it is braided cable or solid cable, such as the type of wires used, the number of pairs of wires, and the fire rating of the cable. With standard unshielded twisted pair cable, or UTP cables, they come in one of two types, either solid core or strand core. The TIA standard specifies that for horizontal cabling, solid core should be used. Here you see an example of both solid core and strand core UDP. Next, you have the telecommunications room. Basically, it's nothing more than a safe, stable platform for all the different hardware components to live. This is where you're going to find your equipment racks. The standard equipment rack is 19 inches wide, however, the heights can vary greatly. Here you see a floor-to-ceiling rack versus a short equipment rack. These racks are what's going to house all of your network components. You will hear a term called U's. A U is 1.7 inches. So a device that fits in a 1.75 inch space is called a 1U device. If it requires 3.5 inches of space, we would refer to that as a 2U device, and so forth. Next, we have to have some way to connect all these devices together. We do that via the patch panel. The patch panel, sometimes called a 110 block or a 110 punch-down block, is where you're going to connect all of your Cat5 cabling. These also come in CAT ratings just like the cabling does. And the CAT rating of your punch-down block must match the CAT rating of the cabling that you're using. To connect your Cat5 cabling, you're going to use what's called a punch-down tool. Once you've installed the patch panel, you need to connect the ports. Although most people prefer to simply buy pre-made patch cables, it really is pretty easy to make your own. All you really need is an RJ45 crimper, some snippers, and a little bit of patience. So I'll show you exactly how to make your own RJ45 cabling. First, you start with your crimper and some snips. You're going to cut the end off of a piece of Cat5 cabling. Next, you'll strip away all the excess sheathing that you don't need, and you'll insert the individual strands into the end of an RJ45 connector. Once properly inserted, you'll use a crimping tool to make sure the strands stay in place. And you're done. Well, kind of. It's always a good idea to put what's called a boot on the end of your cabling. This is going to help protect from snagging the Cat5 cable. Next, we have your work area. The work area is a wall that serves as a termination point for the horizontal cables. It really consists of nothing more than one or two female jacks to accept the cable, a mounting bracket, and a faceplate. Here's a look at a typical work area outlet. On the top, you see an RJ11 connecting a phone line, and below it, you see an RJ45 connecting the network. By far, the work area is the simplest part of the structured cabling system, but it is also the source of the most network failures. Next, we'll talk about TCP/IP. The Transmission Control Protocol Internet Protocol, or TCP/IP, is the primary protocol of most modern networks. This is the way the Internet works. So at the heart of the TCP/IP, it all starts with your network address. The network address must provide two pieces of critical information. It must uniquely identify the machine, and it must locate that machine within the larger network. This is called the IP address. It identifies your PC and the network in which it belongs. The IP address is a unique ID number for your system. The IP address consists of 4 sets of 8 binary numbers called octets, each set separated by a period. We call this the dotted decimal notation. Your IP address is broken up into multiple parts. Part of your IP address identifies the network, and the other part identifies the local computer. However, don't confuse your IP address with your subnet mask. You can tell the subnet mask because you'll see the number 255. Any part that is all 255s is the network identifier. Any part of the subnet mask that is 255 is your network ID. Any part that is all zeros is your host ID. Every computer on a single LAN must have the same network ID. However, they also must have a unique host ID. When you end up with two computers with the same host ID, you'll have what is called an IP conflict. All of these IP addresses are broken up into what's called classes. You have Class A, Class B, and Class C network address. For Class A networks, they use the first octet to identify the network addresses. Class B networks will use the first two octets, and Class C networks will use the first three. It's important to note that the 127 address range is missing in the class networks. That's because it's reserved for network testing, what we call the loopback. The A+ examination expects you to know the address range of the Class A, B, and C networks. Next, we need to understand how to connect multiple LANs to each other. We do this with a router. The routers read the IP address of incoming traffic and forward it to the proper port. To make a router connect two networks requires somewhat of a configuration process. The main thing to remember here is that every port on the router is a member of a different network ID. Here you see a basic, typical network configuration. Notice the IP addresses. They all start with the same three numbers. Do you remember what kind of network this is? Exactly. It is a Class C network. All of the IP addresses start with 192.168.11. The subnet mask is 255.255.255.0. So remember, the subnet mask identifies the network, the 0 identifies the host. So let's say that I have a network with a network address that starts with 12.124.7, and I want that network to talk to another network with the address of 192.168.11. To do that, I need to put a router between the two networks. One interface on the router will have the network address of 192.168.11, and the other interface on the router will have the network address of 12.124.7. Next, we need to figure out how these networks are going to talk. To do that, we have two different protocols. We have TCP, which is a connection-oriented protocol, and that is what TCP/IP is based on. We also have another protocol called UDP. That is a connection-less based protocol. About 95% of all TCP applications on the internet are going to use TCP rather than UDP. One of the most well-known TCP services is HTTP, or Hypertext Transfer Protocol. That is what gets you on the World Wide Web. There are several ways that you can test your machine's connectivity to the network and the internet. One of the most handy is called ping. So understand that the goal of TCP/IP is to link hosts together, or to link multiple networks. To move traffic between those networks, we need to use a router, and each host sends the traffic to the router, and that router then forwards it on. To configure the TCP/IP settings on a Windows XP machine, you either right-click on My Network Places and select Properties, or you can go to the Control Panel and select Network Connections. In Windows Vista and Windows 7, you'll either right-click on Network and then select Properties, or open the Control Panel and select Network and Sharing Center. Remember, every machine must be assigned a unique IP address, a subnet mask, a default gateway, and at least one DNS. Another handy tool that all tech should be familiar with is the command line interface and some of its commands. One of the most powerful commands is ipconfig. For instance, if I want to renew the IP address of any given machine on a network, I will go to the command line interface and type ipconfig \renew. That will make a request for a new IP address for that device. And if I want to give up my IP address, I simply type ipconfig \release. Here's a look at what happens when I type ipconfig/all in a Windows 7 command line. You see, it gives me all the information of all the network interfaces on this particular machine. The next command line tool that you should be familiar with is NSLOOKUP. With NSLOOKUP, it enables you to determine exactly what information the DNS server is giving you about a specific host name. Simply open the command prompt and type NSLOOKUP and press enter. The next tool we'll take a look at is called tracert, or traceRT. This command describes the route from your machine to the destination machine. It will also give you information on all the devices that you have to pass through along the way, or we call that how many hops you have to take. This is especially handy when trying to troubleshoot network latency. Remember, CompTIA expects you to know how to manually assign TCP/IP settings to a device. So it's important to know all the key information that you must enter into any machine to successfully get it on the network. Again, it includes the IP address, the subnet mask, the default gateway, and at least one DNS server. Every now and again, your machine might give you a strange IP address, an IP address that starts with 169. This is never a good sign. This is called automatic private IP addressing, or APIPA. When you see a 169 address, it simply means that it cannot talk to any other machine on the network. Next, we'll take a look at the two versions of TCP/IP. Understand that TCP/IP was developed in the 1970s. Back then, there were fewer than 1,000 computers on the entire interweb. So it wasn't even conceived that we would need more than about 4 billion IP addresses. However, as of today, we have officially run out of IPv4 addresses. So that forces us to move to a new standard. That standard is called IPv6. The IPv6 standard changes the classic 32-bit IP address space to 128 bits. That's 2 to the 128th possible addresses, or for those of you really good at math, approximately 4.3 billion. Here's a look at what a IPv6 address looks like. You see, we've moved from the classic dotted decimal notation, where we see 192.168.4.27, into hexadecimal notation separated by colons. Next, let's take a look at how to install and configure a wired network. Most importantly is the connectivity itself. The device that provides this connectivity is called the NIC, or the Network Interface Card. It understands a basic protocol, or the language that this computer is going to use, and it must be connected and installed in a client. That's your PC. The NIC is your PC's link to the world. NICs are what we call type-specific. They're manufactured to operate on a specific media and network types, such as a 1,000 base teeth internet. If you've installed a new NIC, it should be automatically detected by any of the Windows operating systems. However, if it isn't automatically detected, in Windows XP, you'll need to go to the Add Hardware wizard and initiate the non-plug-and-play devices or plug-and-play devices that were not detected. In Windows 7 and Windows Vista, you'll go to Start, Control Panel, and Add Hardware for Vista, and Start Devices and Printers, and click on Add a Device in Windows 7. All modern NICs can run in what is identified as full duplex mode. That means they can send and receive data at the same time. The vast majority of NICs and switches use a feature called auto-sensing to accommodate for very old devices that may be operating in half duplex. Half duplex simply means that the device can only send or receive and can't do them both at the same time. Half-duplex devices are exceedingly rare these days, but you do need to understand this option. Next, we'll talk about the link lights. The link lights are little LED status indicators on your NIC. This is the first place you should check whenever you think that you're having a network connectivity problem. Little blinky lights are good, not seeing blinky lights are bad. Most NICs are capable of a feature called Wake on LAN. This is especially useful when doing patch management across a large organization. You don't have to physically go and touch and turn every computer on. You simply send what's called a magic packet to each computer to wake them up. To configure this in Windows XP, you'll go to the Control Panel and open Network Connections. In Windows 7 and Windows Vista, you go to the Control Panel and open Network and Sharing Center and click Manage Network Connections for Vista and change adapter settings for Windows 7. Next is the same for all Windows versions. Right-click on the adapter that you wish to wake up and select Properties. Then you'll click the Configure button in the Properties dialog box and then select Power Management. To enable Wake on LAN, make sure the checkbox next to Allow this device to wake the computer is checked. It'll look like this. To finish establishing your network connectivity, you need a network client installed and configured properly. Installed as part of the operating system, the client for Microsoft networks rarely needs any type of configuration, and in fact, few configuration options are even available. To start it in Windows 7 and Windows XP, click Start, and then right-click on Network and select Properties. Then click Manage Network Connections in Vista or Change Adapter Settings in Windows 7. In Windows XP, you'll go to Start and then right-click on My Network Places and select Properties. Next, for all Windows versions, you'll double-click the local area connection icon, then click the Properties button and highlight Client for Microsoft Networks. Understand, Windows can share all kinds of resources, including files, folders, drives, printers, faxes, and even internet connections. To share a drive or a folder, for instance, just right-click on the drive or folder, then click Properties, and then click the Sharing tab. You then need to determine the permissions. Windows provides for two different sets of permissions, either share permissions and NTFS permissions. Share network permissions offers full control, change, and read settings. If you're on NTFS and want to control the permissions even further, you need to configure the NTFS permissions in addition to the network share permissions. If you want to share a drive across the network, in Windows 7, simply go to the Map Network Drive applet, select a drive number that you want to assign it, and then enter its address or its path. Or, if you don't know its path, it will allow you to browse for the specific folder or file that you're looking for. An even easier way to do this is to select the link for networks in the File Explorer. That will bring up all available resources, and then you can browse each file on that resource. Then just simply drag and drop it into your shared folders. However, it is important to understand how to do this manually. You will need to know what's referred to as the Universal Naming Convention, or the UNC. The UNC uses the computer name and the share name. For instance, I would type / whatever the server name is, / whatever the share name is, and then / whatever file name I'm looking for. This is the same to provide shared access to network directories as well. However, if you don't know the UNC of a particular drive or folder, you can always go back into the command line and find it for yourself. To do this, we use what's called the net commands. First, netview. That will list all the available shared folders on that network. And then we'll use the netuse command. This is used to map to that particular network drive. Another important command to understand is the command nbstat. This command itself goes back even before Windows. It's a great little tool for learning anything Windows related you want to know about your network. Want to know what other workgroups or domains are on the network? nbstat will tell you. It stands for NetBIOS over TCP/IP statistics. So now that we know how to share files, folders, directories, and drives, now let's take a look how to share a printer. Sharing a printer is very similar to sharing a drive. Just right-click on the printer, select Properties, and then Sharing. Then you'll select Share As or Share the Printer and give the printer a name. Remember, you need to use the UNC standard. Then the setup applet should just copy the printer drivers required from the network computer. If not, it will prompt you to enter a driver disk. Next, let's take a look at troubleshooting networks. First, we'll deal with the total loss of connectivity. You'll know this because you'll start seeing pop-up warnings, for instance, in Windows XP, or Windows 7 will simply show a computer with an X over it. Be sure to check the obvious things first, like, is the cable unplugged? Or maybe the less obvious things, like, is the NIC disabled in the device manager? One of the classic signs of an actual physical problem is when you get intermittent errors and a warning or an error that says no server is found. Next, if you've verified that the cable is plugged in and the NIC isn't disabled, check the link lights. If there's activity or you see the lights blinking, then it's a different problem. Perhaps you have a failed switch or failed switch port. One way to identify that is to see if other people can access the network. And then lastly, if all of that fails, plug the system into a known good outlet and see if that solves the problem. It might actually be the switch port in the wall. Next, you'll need to determine if you possibly have a bad NIC. To do that, we do what's called a loopback test. To do a loopback test, you need a loopback plug. If the loopback test fails, the NIC is bad and you need to replace it. This is what a loopback plug looks like. There you have it. It's pretty simple. Remember, everything starts with the basics. Once you